Tomorrow will be better. An elephant of weight 3000 Newton stands on 1 foot of area 0.25 meters square. What pressure is exerted when it stands on 4 feet? Dear friends, unlike what many people will expect, that when it stands on the 4 feet, the pressure will be more on the ground. It's the opposite. Let's investigate this. Follow me, dear friends. Solution. Let's start by recalling the formula for pressure in this case. Pressure is the force per unit area. In this context, our force here is the weight of the elephant because it is the weight which has been given and not the mass which has been given. Watch out for this unit. So it's 3000 Newton. Now, what about the area? To further or to clearly demonstrate the change in the pressure, we will calculate the pressure when it stands on this 1 foot, and then we will also calculate the pressure when it stands on all 4 feet. Now, the area when it stands on just 1 foot, 0.25 meters square. Therefore, the pressure exerted by this elephant when it's on its 1 foot is given by the force 3000 Newton divided by the area 0.25 meters square. If you do this correctly, you should have 12,000 Pascal. Pascal is the SI unit for pressure. Now, the new area, if it stands on all 4 feet, will be equal to the area of 1 foot, 0.25, times all the 4, which should give us 1 meter square. We are going on the assumption that all the 4 feet have roughly the same surface area. So the new pressure now of this elephant when it stands on all 4 feet will be equal to, once more, its weight, which is still 3000 Newton, divided by the new pressure, which is divided by the new area, which is 1 meter square. And this is nothing else but 3000 pascals. Clearly, now that the elephant stands on its 4 feet, the pressure has significantly dropped to this. This is the clear demonstration that the greater the surface area of contact between a force and a surface, the smaller the pressure that the force makes on that surface. Tomorrow will be better.